All right, so today we're just going to quickly cover two different functions on our Ti-84 graphing calculator that we can use with derivatives. So just for like a placeholder, I'm just going to enter some equations here and you can just follow along. I'm just going to choose a nice easy polynomial. I'm just turning everything off and clearing my calculator. Let's just do something as simple as like 3x squared minus 6x. So I'm just going to get a graph of it. Now on mine, as it's graphing things, my key press history will be here. So like if I tell you where a button is, you'd be able to go find that button just based off the key history. So the first key that we want to learn today is just how do we evaluate a derivative. So like I'm just going to use the point or the x value right here of 1. We can see that that looks like it's the minimum of this graph here. So what I'd be able to do, like just visually looking at it, we know that's where the tangent line would be 0. So I have an idea that the derivatives value there should be 0. So the first button for today is where we calculate things on a graph. So we hit second, and then the trace button, which once I hit the blue now means the calculate word. And then here you can see right away, number 6 has the derivative formula dy dx. So what it's going to do there, it's going to find the rate of change at the input value that you tell it to. So if I choose option 6, it'll ask me what the input value is, and I can go ahead and scroll left and right, but scrolling left and right doesn't have any accuracy to it, so I can also just type in the x value that I want. So the derivative's value here, as it sneaks it up there, is 0. So again, hitting second and calculate, you can calculate the derivative at any point on the curve. So if I'm looking for that derivative just somewhere around here, maybe it's 2, it'll tell me right at 2 the derivative's value is 6. So that's the first really important button that's good to know. That's really just for like checking answers and stuff. Let's say you have a more complex derivative and you wanted to see if the value that you calculated was correct, you could do that. Now, there's another way to do that from the home screen. And from the home screen, we can be a little more robust. We don't need to actually enter a graph. So in the math key, so I'm just going to clear my key press history here. If I hit the math button, it brings up a bunch of operations. And we can see that option 8 is n deriv, which is going to calculate the nth derivative for us, or it's going to calculate a derivative for us. So in this form, like I have a brand new calculator, so it gives me a nice like wizard on like where to input things. So like here, I need to tell it what equation or what values I want to differentiate with respects to. So like I'm going to differentiate with respects to x, and then I need to type in my function. So I'm just going to choose that same function that I typed in before, which is the 3x squared minus 6x. And then it's going to ask us, we can see that notation, what x value do you want to find the derivative at? So like again, if I chose 1, it would go ahead and evaluate the derivative of this function at 1. Now that's not the derivative function, that's the value of the derivative. But with this button, again, math, and I went down to the n deriv, which is option 8. You have to type in what variable you want to differentiate with respects to. So in that case, then you're going to use that variable in your expression for the function. And then this is the input value that you want to evaluate that derivative at. Now that button can actually be somewhat not abused, but can be used to make a graph of the derivative. Like I know with this one, we'd be able to calculate the derivative and graph it on our own. But if we go into y equals, we hit that math button again, and we go down to n derivative, we'll notice that it brings up that same expression here. So I'm just going to type in, I want to differentiate this function with respects to x. I'm going to type in the equation of the function. Now, what I wanted to do is I wanted to calculate the derivative at every x value and then plot that value. So rather than giving it a specific x value, the way that our calculator actually graphs stuff is just by the brute force method, where it actually just goes into super small values of x and just evaluates things and plots it. So I wanted to evaluate the derivative at every x value. So I set it equal to x. Now this method is going to graph the derivative for us. It's just going to do it really slow because the calculator, again, is using the brute force method where it's literally just going through and plugging in a bunch of numbers. So when I hit graph here, again, going really slow, you can see my calculator still working, but it will graph the function for me. Now we can just kind of compare it and see what it's doing here. If I go back to second calculate, and I calculate the derivative, right, we know that the derivative at 1 was equal to 0. So then if I think about what would the line, right, this equation here is supposed to be the derivative, which we can see it is because it's a nice easy line for us to calculate the derivative, right, the 6x squared minus 6. But if I just go to second trace and I just calculate the value at x equals 1 of what it said my derivative was, so not this original function, my derivative is stored in y2. And you can see that I do get 0. Now the reason I have this here as well is when I went to the home screen and I went into math and then I went down to option 8, which is the nth derivative. Certain calculators, if they're old, won't give you that nice little wizard. So it's going to ask for input values. And if you're going to type it in, like if it comes up and that little wizard isn't there for you, the first thing you type is the expression of the function. The next input value is the variable letter. And then the last input value is the value that you want to calculate the derivative at. So like the first thing we did was we typed in 3x squared minus 6x. The variable we were differentiating was x. And the first example I did was at 0. If I didn't get the wizard, that's what I would type in for my argument. So as you can see, it's just showing you up on the top here when I evaluated it at 1, and by it I mean the derivative function. See here it can't format that nice little fraction and stuff, so it just showed us the arguments where this was the function, we were differentiating with respects to this, and then this was the value at which we evaluated it. And this one says x because remember we evaluated it at everything. So you can use that to help make graphs of like more complex functions, like maybe, I don't know, I'm just going to do something weird like the log of x squared times the cosine of x. I don't really know what it looks like, but that function, maybe let's get a bigger window here because it's going to start growing up and down. Let's just go up to 50 for a second so we can see it. I don't know what the derivative of that function looks like, but I could easily make a graph of it by simply abusing that power of the derivative. So I'm going to differentiate with respects to x. I believe here I can also just go and use shortcuts like my y variables, like I've hit alpha trace y4. Sorry, I don't want y4. My equation's in y2. But again, you can use those shortcuts. So the easiest way, alpha trace brings up your y variables, or you can hit the vars menu and go over to the y variables. When we write it in terms of y, that's a function. I have my equation stored in y2. Or again, you could just literally go back and type that expression instead of y2. Now we'll see that coming in black. Right, and we can see that sinusoidal type graph just because we know the derivative somewhere is going to involve some trig functions there. But that's the derivative of that function. So again, those two functions are what we're using for today, just as the beginning of calculus functions on our calculator.